Note section 3.4 here in geometry, we got parallel lines and triangles. Those parallel lines are not in the triangles. These are separate topics. We got parallel lines, we got triangles. Postulate 3.2. Given line M and a point A not on the line, so let's draw that first. Here's line M and a point A, which is clearly not on that line. Remember, a postulate is something that once you read it, it's so obvious there's no need to prove it. There is only one line N that goes through point A and is parallel to line M. So there's only one line in existence that we can draw that's parallel to M and goes through A. And that would be called line N. It doesn't have to be called line N, we're calling it line N. That's a postulate. Angle sum theorem. This is huge. This is huge in importance. It's also known as the triangle sum theorem. The sum of the interior angles of a triangle is 180 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. That's true no matter what type of triangle you have. So an example of that, find the missing angle. We'll call that angle X. Well, according to the angle sum theorem, if you add up all the angles in a triangle, that will be 180 degrees. 45 and 95 is 137. You subtract 137 from both sides, you're going to get 43. So the missing angle would have to be 43 degrees. Complete this proof, write small. This is a 9-stepper. It's a complicated proof. This is a proof of the angle sum theorem, that the sum of the angles in a triangle is 180. That's what we're trying to prove. So given that we have the triangle XYZ, and given that line YA is parallel to line XZ, we're trying to prove the sum of the angles in the triangle is 180. So step 1, once again, I'm not kidding when I say write small. You're going to have to write tiny. We're going to take what's given, which is we have a triangle, and we have a couple parallel lines. Now, does the picture show those lines are parallel? It does not. So let's put that into our picture. That could help us. Does the picture show that we have a triangle? Yes, no need to put that in the picture. Now, the advice I've given you in the past is try to make equations from what's given. And that is not an easy task in this case, so let's just work with me here. Would you agree that angle 4 and angle AYX, these are a linear pair? Angle 4 and angle AYX are a linear pair. How do I know that? It's a definition of a linear pair. You can tell just by looking at the picture it's a linear pair. I can tell that because I know the definition. According to the supplement theorem, if you have two angles that are a linear pair, then those two angles are supplementary. So angle 4 and angle AYX are supplementary. Reason? Supplement theorem. What does the supplement theorem tell us? I'm sorry, what does two angles being supplementary tell us? It tells us that if we add their measures, we get 180 degrees. That's the definition of supplementary. Now, it took us a long time. It took us 4 steps. But we finally got to the fact that we have an equation. All right, so we know now that this angle and this angle added together is 180. Is there a way for me? Yeah, I want to break this apart if I can. So check this out. Would you agree that the measure of angle 1 plus the measure of angle 5 equals the measure of angle AYX? It's the angle addition postulate. This is a tough proof. That's why we're doing it together. I don't think at this point this would be something that would be easy for you to figure out. What's the reason for that again? If I give you the step, you should be able to give me the reason. That's the angle addition postulate. Now, I can take this equation and write her down. I'm not going to write everything down. I'm going to do some substituting. I'm going to replace measure of angle AYX with measure of angle 1 plus measure of angle 5. Substitution, property of equality for real numbers. Now 7, here's why we should be excited right now. I got measure of angle 1 in the equation. What I'm trying to prove has measure of angle 1. I got 180 on the right. What I'm trying to prove has 180 on the right. My only problem is I got this angle 4 in here, which I need to be an angle 2 or 3. And I have angle 5 in here, which I need to be the other angle, 2 or 3. Check this out. We get 2 parallel lines cut by a transversal. Angles 4 and 2 are alternate interior angles. They're congruent. 2 parallel lines cut by a transversal. Angles 5 and 3 are alternate interior angles. They have to be congruent. So I could say that, hold on one second. I could say that angle 2 is congruent to angle 4. And I could say angle 3 is congruent to angle 5. Same reason for both. The alternate interior angle theorem. Now, unfortunately, I need to change these to equations so I can use them in this. So this is actually going to be 10 steps, not 9. The measure of angle 2 is going to equal the measure of angle 4. Measure of angle 3 is going to equal the measure of angle 5. Please quit sighing, students. Please quit sighing. This definition of congruent angles that says we can change from pictures that are congruent to numbers that are equal. Now, we can take this equation, we can replace measure of angle 4 with measure of angle 2, measure of angle 5 with measure of angle 3. We're going to have measure of angle 2 plus the measure of angle 1 plus the measure of angle 3 is 180. We just did a double substitution. So that's substitution, property of equality for real numbers. Now we're close. What we're trying to prove is 1, 2, then 3. We got 2, 1, then 3. Do we have a property that says we can switch this order around? We do. It's from algebra. We haven't discussed it yet this year. But if you have addition and you want to change the order of 2 consecutive things, you can do that. And when you hear the reason, it will sound familiar even if you're not exactly sure this was the reason. The commutative property. Of equality for real numbers. Let me change this to be more consistent with what I was writing. We have now just proved that the sum of the interior angles of a triangle is 180 degrees. It's a tough proof. Find the value of x. Example 3. Well, we have three angles in a triangle. According to the angle sum theorem, if we add these together, we're going to get 180. So we got angle 1, angle 2, angle 3. The order of these angles does not matter. A -9 and a +76 and a +47 is a +114. You subtract 114 from both sides and then divide it by 6, you're going to get x is 11. Just ask for x, so we're finished. All right, we got a little bit of more action here. Auxiliary line. When you extend a segment in a figure. Exterior angle of a polygon. This is tough to define, so let me draw a polygon. If I were to take and make an auxiliary line, it's when I take a segment in a polygon and a figure and I extend it. This is called the auxiliary line, even though it's a segment. The one I drew is a segment. Put an arrow on each end and it becomes a line. This angle right here would be an exterior angle. Just another example, let's say we have a triangle. And if I take and extend this here, this is the exterior angle. Which leads us to another definition that's difficult to put into words. Remote interior angles. Remote interior angles always start with an exterior angle. So in each case, we're going to start with this exterior angle, angle 1. Remote means far away. So what are the interior angles that are furthest away from angle 1? It's angle 2 and 3 in every picture. So in each picture, angle 2 and angle 3 are the remote, far away, interior angles to angle 1. What will we call this angle right here in relative to angle 1? We call it a linear pair. So it's the nonlinear pair, which leads us to the exterior angle theorem. The measure of an exterior angle, if you have a picture like this, is equal to the sum of its two remote interior angles. So the exterior angle 1 is equal to the sum of the measure of angle 2 and the measure of angle 3. Here's why that should make sense. Angle 1 plus this angle adds up to be 180. This angle plus these adds up to be 180. So we have this angle is supplementary to 1, and in a sense, this angle is also supplementary to the sum of 2 and 3. Hopefully that makes sense. This can save you some work. If you didn't know this theorem, the exterior angle theorem, you could still get problems done correctly, but it does save you time. Find the measure of angle 1. There is no angle 1 in this. How about find the value of x? Well, according to the exterior angle theorem, 93 should equal the sum of x and 34. You subtract 34 from both sides, I believe you get x is 59. Number 5. Find the value of all the variables. So this is chock full of vitamins here. Where do we start? Let's start here with b and 32. b plus 32 has to be 90 because for one of two reasons. One reason could be because the angle sum theorem, 32 plus b is 90. Another is definition of complementary angles. 32 and b make up this 90-degree angle. So b ends up being 58. Once you find a measurement, it's a good idea to put this into your picture. Now I could say, looking at this triangle, if I add up all the angles, the angle sum theorem, I should get 180 degrees. 55 plus 58, I believe, is 113. If I subtract 113 from both sides, I believe I get 57. I'm really not good with numbers, ironically. Put that into my picture. Now, if you look at this big triangle, what letter? That's a D up there? Yeah, D degrees. Looking at the big triangle, we got 57 degrees, 90 degrees, and angle D. Angle sum theorem again. Measure of angle, well, we don't have, let's just say D plus 90 plus 57 equals 180. 90 and 57 is 147. We subtract 47 from both sides, 147 from both sides. We're going to get that this is 33. Put that to the picture. Let's see, we're missing angles C and D. These two angles, C and 55, are a linear pair. So the supplement theorem says that those have to sum to 180. So C plus 55 is 180. Therefore, C is 125. And then angle E, we'll check this out. Since this is 90, 90 plus 90 is 180. So we could say E plus 90 is 180, which makes E 90 degrees. Let me just make sure that this is right. I didn't put C in my picture. So do these add up to be 180? So 33 and 32 is 65. 65 and 125, that's not 180. This right here is not right. 147, this should be 23. This was a mistake. 23, no, that's not right. Something's afoot. Something is wrong here. I said that D was 133. Or, I'm sorry, just 33. But if I add up these, let me just bring my calculator. I'm sorry about this. Something doesn't look right. 33 plus 32 plus 125. That's 190. So I got 10 too much. Let's see if this checks out. 33 plus 57 plus 90. It's 180. That works out. Do these add up correctly? 55 plus 58 plus 57. Oh, that's 170. So I apologize. This should be 67. And because that's 67, that makes this 23. Wow, I apologize. I think that fixes everything now. Sorry for the waste of your time. It's a nice thing about showing your work. A lot of times you can work backwards and find your mistake. That one took me a while to find. Find the missing angle here. If you add up all the angles, we'll call this x. According to the angle sum theorem, they should add up to be 180 degrees. 74 and 42 is 116. If I subtract 116 from both sides, I believe we get 64. But as noted on the previous problem, I am prone to mistakes. Find the value of x. This is the exterior angle theorem that we just learned. This exterior angle is equal to the sum of its two remote interior angles. So 131 should be equal to the sum of 8x minus 3 and 5x plus 4. 8x and 5x is 13x. A minus 3 and a plus 4 is a plus 1. Subtract 1 from both sides, divide both sides by 13. I believe you get x is 10. That concludes the notes. Please do the homework. Do not sleep on the exterior angle theorem. It's a good one. Problems can be done without knowing it, but it can save you some time. We all like to have extra time.